Hi, welcome back to our series on robotics with Arduino. I am Jason Vasalio, and for this experiment, we will be controlling the speed, direction, and angular displacement of a 5-volt stepper motor using the L293D quadruple half-H driver, as well as the Arduino Nano. Alright, so our objectives for this experiment is to control the direction of rotation of a stepper motor using H-bridge circuit, to control the speed of rotation of a stepper motor, to control the angular displacement of the stepper motor, and to create a computer program user interface to send data control to Arduino. Alright. So, for this experiment, we will have three main parts: the direction control, speed control, and the angular displacement control, all of which has schematic diagram, circuit assembly, and programming. But for the last part, we will have an additional part which will be for our user interface and the combination of all these three. Alright. So for this experiment, we will be needing these materials: breadboard, L293D jumper wires, nano board, and 28BYJ48 DC step motor. For our experiment, we will be using the 5-volt DC step motor. So right here we have the schematic diagram of the L293D, just like our last experiment number 1. We used this for the control of the DC motor, but we use as you can see on the right side, we have this internal schematic of the L293D, but we use the left side, which is the bidirectional DC motor control. But for this application, we will be utilizing the unidirectional, or at least that configuration, for controlling 4 of the inputs of the stepper motor. So as you can see here, we have this stepper motor, and according to the internal schematic, which has a red or plus 5 volts, positive 5 volts center tap at the coils, this is a unipolar stepper motor. Now for this model, we have a gear reduction of 1:64, and a step angle of at full step mode 0.176 degrees, and steps per revolution at full step mode is 2048 steps. So for experiment, again, we will be using the Arduino Nano, and this is the pin out diagrams of the board. We will be utilizing the D9, D10, D11, and D12, as well as the positive 5-volt supply and the ground of this board. For the direction control schematic diagram, we have this schematic diagram, and as you can see at the bottom right, we have the stepper motor. And if you will notice, it's not the same model that we just showed you a while ago, and this is because we couldn't find any similar models in the software that we used for schematic diagram. However, this will be the same with that, except the center tap is not combined at the end of the wirings. But here we combine them just like how it will be for our model of the stepper motor. So as you can see here, our coil A is connected to out 3, and our coil B is connected to out 1, and our coil C is connected to, let me see here, is connected to out 2, and letter D or coil D is connected to our out 4. As you can see, all of the in1 or input 1, 2, 3, and 4 pins of the L293D, all of them are connected to the Arduino Nano at D9, D10, D11, and D12. You can also see here that the enable 1 and as well as the enable 2 is connected to the positive 5 volts, as well as the ground to Arduino and L293D. Alright. Also, the center tap of the unipolar step motor is connected to the positive 5 volts of the Arduino Nano. Alright. So, for this direction control circuit assembly, we used this tiny or the half breadboard, and we connected the Arduino Nano or the Nano board to the board, as well as the L293D. As you can see here, the wirings are the same as the schematic diagram. Alright. You can pause if you want to analyze where the connections are, but it's generally the same as schematic. For the direction control, programming and demonstration, we will show you the sped up video of the programming coding for the direction control as well as the demonstration. Alright, so now that we have finished coding for the speed control, let me now walk you through the entire program. So for the first part, we have here 4 macros, IN1, 2, 3, and 4, which will be for the stepper motor. So our pin configurations will be 9, 10, 11, and 12 respectively for each inputs. So this right here is the direction in Boolean, counterclockwise as true and clockwise as false. Alright, so next is the function prototypes. We have made 2 additional functions which are the run motor and the step. The run motor, which accepts a variable of a Boolean variable, and a step function which accepts an unsigned 8-bit integer variable steps. So first, let's go to the additional functions. Here is the run motor. This will be responsible for the consecutive steps of the stepper motor in order for the stepper motor to move forward or reverse properly. And right here is the step function, which will be responsible for activating of the L293D into the motor itself. As you can see here, we have digital right, high, low, 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 and that goes on for 3 consecutive number cases. Here is for 0, 1, 2, and 3, which will be called in the run motor function. Alright, so the next is initialization for steps. Right here we have created a struct named step, and we created a step struct called step as well, which will be accessed as you can see here in run motor function. So let's go to the setup. Pin mode, IN1, 2, 3, and 4 are all outputs, and serial begin, which will initialize communications between PC and the Arduino. Here we have the loop. If serial available, if there's any serial input, it will store that string input into strcont, and that strcont, the first character of that strcont array position 0 will be stored into a character variable called par, and that par, if par is greater than or equal to a and par is less than or equal to c, then it will store the first character of the string strcont into the cont variable, which is a character variable. And after that, it will execute the following, which is a switch case for cont. If it's A, it will run motor in counterclockwise direction. And if it's B, it will run the motor clockwise direction. And if it's C, it will simply just block the microcontroller, and it will not do anything unless we enter a new character. Alright, so let's upload that to the microcontroller. Okay, alright, so let's initialize the serial communications. So if I press A, this should rotate, like I said, counterclockwise, and if it's B, it should rotate clockwise. Now, as you can see, it's rotating counterclockwise rather, because I pressed the key or the A key of the keyboard. And if I press B, it should run clockwise direction. And if I press C, it should stop. Again, A, B, A, C, A, B, B, A, and C. And as you can see, it's working properly. So now we can proceed to the next part of the experiment, which is the speed control of the stepper motor. Now, if you will notice here in the program, you have the speed variable, which is an unsigned short, speed, which is equal to 3. So for this stepper motor, I found that the 3 millisecond delay was the lowest possible delay that this stepper motor can handle. Any lower than 3 millisecond will cause the motor to stop, or it won't be able to execute such a fast speed. Alright, so let's proceed to the next part of the experiment. Alright, so for the schematic diagram of the speed control, this is similar with the direction control, nothing really changed, as well as for the speed control circuit assembly, nothing changed, it's still the same. It will be using the same circuit assembly and schematic. And for the programming demonstration, again, we will show you the sped up version of the coding and the demonstration itself. Alright, so now that we have finished coding for the speed control program, let me now walk you through the entire code. So again, we have these 4 macros for the I/O pins of the Arduino to the stepper motor and L293D. Alright, so right here we have these function prototypes. As you may have noticed, this run motor no longer accepts any variable, unlike a while ago where we accepted a Boolean variable rot, which stands for rotation. For this, we will simply just run this function regardless of the direction. So right here, initialization for steps, we have ULN8 forward. We also removed the other parts of this struct, since we will only be dealing with one direction, which is forward, for us to be able to focus on the speed. Again, string strcon, unsigned short, speed, and a character variable named par. So again, we have this setup pin, mode, output, and serial begin, which initializes the communication between the PC and the microcontroller. And the loop where if there's a serial input, it will store that string into strcont variable, and the first character of that string will be stored into the par. Now, if that par is equal to s, it will execute the following codes. So, first is that it will store the substring 1 at position 1 onwards, and convert that into integer and store that into the speed variable, which is a ULN20 or an unsigned short speed rather, and the speed will be converted into a range of 3 to 33. Now, right here, if speed is less than or equal to 100 and speed is not equal to 0, it will execute the following. It will store the converted value into, again, the speed variable. This conversion right here, if you will notice, we have 101 as well as 3 and 33. Now, the 3, again, we explained last time that this value is the lowest possible millisecond that the stepper motor can run. Now, for this 33, there's no really, I just assigned 33 as the slowest, but it can be slower than 33 milliseconds for the delay. So there's that. And if the speed is equal to 0, it will again simply just block the microcontroller and wait for any serial input again. So for the next parts, we have here the run motor. Again, we have modified the run motor to just run regardless of any direction. So we didn't put any input variable for that function. Right here is the run motor function. As you can see, it's just the step forward now. It doesn't have the step reverse just like a while ago. Alright, so for the delay, we have the speed variable, which will be modified when we enter any numbers. Alright, so let's try. Again, well, step is just the same, it didn't change. So with that, let's try to upload it to the microcontroller. And initialize the serial communication. Alright. So if I type 100, as you can see, it did not perform any movement. And that's because we didn't press S first. We must be able to press S first because that's what the par variable will be, because that will be the element that will be stored into par, which will execute the following if it's an S. So let's try to press S first and type 100 for the maximum speed. And as you can see, it now starts to move. The stepper motor now starts to move. And if we press S50, it moves half the speed of the fastest speed. Alright, so if we press S0, as you can see, it stopped. But if we press S and 1, it runs but at the slowest speed. So again, S40, S50, S60, S70, S80, S90, and S100. Alright, so now that we have completed the part of the experiment for the speed control, we can now proceed to the angular displacement part. Alright. Now, for the angular displacement schematic diagram, same with the previous two, we will be using the same schematic diagram as well as the same circuit assembly. Now for the programming demonstration, we will show you again the sped up coding and demonstration. Alright, so now that we have finished coding for our angular displacement program, let me now walk you through the entire code. So again, we have this 4 inputs for the stepper motor and the L293D. And again, as you can see, the direction in Boolean is back counterclockwise for false and clockwise for true. And now, as you can see, we have a new function called the run motor angle, which accepts an input of a 16-bit integer called input angle. For the initialization of steps, or 4 steps, for our struct, as you can see, we have 2 additional variables called total and angle. Both has an initial value of 0. So if we go ahead to our loop, as you can see here, if again there's an input available at the serial, it will store that string into strcont and convert or store the first character of that string into par, where if par is equal to L, which will be our control parameter for angle, it will store the substring at position 1 onwards to angle, or convert that first into integer and store that into angle. Now after that, it will call the function run motor angle and input this variable. So if we go ahead to the run motor angle function, as you can see here, we have a new variable called dir, which is a Boolean variable, and the step.total is initialized again to 0, and this is for the entire program to work properly in case that it's already called more than once. So for our first, if input angle is greater or equal to 0 and input angle is less than or equal to 360, it will convert that range from 0 to 360 into a range of 0 to 2048, which is the steps per revolution of our motor. And the 0 to 360 will be the complete cycle of the thing that you can see here right now. So if input angle is positive, it will store, or it will have a direction of clockwise, as you can see here. Else if input angle is greater than 360, it will have a new, as you can see here, we made a new variable called cycles, which is equal to input angle over 360, and it will be inputted here in the conversion of our ranges. So this will just execute the additional angles of the input angle more than 360 degrees. So if we inputted 720, it will run the motor, or it will run the cycle twice clockwise. Alright. So else if input angle is less than or equal to 0 and input angle is greater than or equal to negative and 360 degrees, in case that our angle is negative, which means that it will go back, it will just convert first the input angle into the positive. It will get the absolute value, and again input that into our conversion, but our direction will be changed to counterclockwise. Else if this is just the same as the second if statement, except it will of course again convert the input angle to positive first, and the direction will be counterclockwise. So here we see a while loop. If step.total is not equal to step.angle, it will run the motor and have an input of dir, which will be depending on the inputs of our angle, and have a delay of speed. After that, it will increment the step.total. Now, if the step.total is already equal to step.angle, it will stop performing this function, and it will, or performing this loop, and it will stop the motor. Alright, so let's see that in action. So, alright, upload this to our microcontroller and initialize or open the serial communications. Okay, so if I press, let's say 90, if I enter 90, as you can see, it did not do anything. But if we enter L90, it moved counterclockwise 90 degrees. So if we again input L negative 90, it will go back to the position where it was before. And if we input L negative 90, again, it's now in 0 degrees. If we input, let's say, 360, or L360, it should turn a complete cycle. Now let's try entering more than one cycle. Let's say 360 plus 90, which will be equal to 450. Alright, so if we enter L450, it should turn a cycle plus a 90-degree angle. Alright, so as you can see, it's working properly. And now that we have finished all the parts, we can try combining everything and controlling the microcontroller or the stepper motor using a GUI, which we will be doing as well. Alright, so now again that we have finished all the main parts of this experiment, let's now go to combining all of the controls, and controlling them using a graphical user interface, creating this GUI using the Visual Studio. Alright. Alright, so now that we have finished coding for the entire program of all the parts of the experiments, which are the angular displacement, speed, and direction control, let me now walk you through the entire code, which should only be short since we have already discussed all parts of this program from the previous parts. Alright, so again, we have this 4 inputs: the direction, the function prototypes, initialization, first steps, all the parameters, all the variables, as well as the setup, pin mode, all the outputs, and the serial begin. Now, if we go ahead to our void loop, we can see that if the serial dot available, if there's any input serial, it will go all through all of this code. And if you will notice, all of this is just a combination of everything that we just did from the previous codes. So A to C for the direction, L for the angle, S for the speed, and Right here is a switch case for the direction control. Now if you go here to our run motor, again we have all this step dot forward, step dot reverse for the direction, and the run motor angle, which we just discussed from in the previous part, and again the void step. Okay, so if we go to our Visual Studio, as you can see here, we have already completed the design, and right here we have the direction control, speed control, angular displacement. These two are the input for our text box. So we can input anything in this text box, any number. And as you can see here, if we click clockwise, counterclockwise, stop, stop, and stop, this will all execute accordingly as expected. And if we go here at our form1.c#, we can see here at public form1, we have we opened a serial port 1 for us to be able to communicate with the Arduino through the GUI. And if we go to the properties of the port, of the serial port, as you can see here, its port name is at COM5, which is where our microcontroller is right now, and is always at default at COM5 in my case. So going back, alright, so the next thing is the button 1 click, which is a stepper motor at clockwise. Right here, this is the step, or this is the button 1, and this is the button 2, 3, 4, and 5. So for the button 2, we have write A to the button 2, we have write B to the serial port, button A, or button 1's write A to the serial port. At the button 3, we have write C for the stop. This is for the stop. And for the button 4, which is also a stop, but we will use the stop of the angular displacement, or the speed rather. And here we have a text box 1 dot or underscore key down. This means that well, let's look at the properties so you can understand it better. Alright, so as you can see here at events, key down is text box 1 key down. This means that hold on. Alright, the key down occurs when a key is first pressed. So if we go back to our code, text box 1 key down, if E, which is key event args, E dot key code, which is key code, equals keys dot enter, which is our enter key in the keyboard, it will execute the following. It will store the S in our cont, which will be appended by the figures that we type in our text box, or the characters that we type in the text box, and write that cont, which is a string, write that cont into the serial port to the Arduino, to the microcontroller. The same will be for our angular displacement control, which will have a parameter of L and append the figures or the characters that we input in the text box .text. And for the last part, we have the stop of that angular, which will be C, if we want to suddenly stop the execution while it's still running. Alright, so if we start this program, click on start. Alright, so if we go ahead to our GUI, as you can see here, we have the direction control, clockwise, everything that we just discussed. And notice the stepper motor when I press the clockwise. As you can see, it's running properly, right? So if we press stop, it stops. If I press counterclockwise, it rotates at a different direction. If I press stop, it stops. And if we set the speed to 50, enter, and hit clockwise, the speed is much slower and the direction is at clockwise. So if we press stop and enter 100 for the speed control, clockwise, again, it rotates at the highest speed. If we press stop, it stops. But if we enter an angular displacement, let's say 180, hit enter, it will rotate 180 degrees. If we rotate negative 180, it will rotate clockwise 180 degrees. Alright, so let me just fix that angle. Oops, negative 5. Alright, so if we enter 720, or let's say 730, we should expect this to turn 2 cycles plus 10 degrees. Now for the second cycle plus 10 degrees. Alright, so as you can see, we have that right there. So negative 10. Now if we press, or if we enter 45, or let's say just negative 45 degrees, it will still rotate. Negative 45 again, enter. So as you can see, the GUI is working very nicely with the microcontroller using the serial communications of this GUI as well as the microcontroller. So that will be it for our experiment. Thank you for listening. See you on the next one.